Right now, a war is being fought. Not with missiles, not with soldiers, with something far smaller, something so tiny, it makes a human hair look like a skyscraper. A war fought over a piece of silicon smaller than your fingernail. A chip, a semiconductor. And the outcome of this war will determine which country controls the future of artificial intelligence, robotics, and the entire global economy. This is the semiconductor war, and it is already underway. But here is the strange part. Most people have no idea it is happening. You use its products every single morning. Your phone, your laptop, your car, and none of them would exist without semiconductors. And right now, the biggest governments, the wealthiest corporations, and the most powerful militaries on Earth are betting everything on controlling them. So today, we are going to break it all down. Let us start with the basics. Who actually runs the semiconductor world? You might think it is a big American tech company. Maybe Intel? Maybe Apple? Maybe Google? But the truth is far more interesting and far more fragile. Meet TSMC, the Taiwan Semiconductor Manufacturing Company, a company you have probably never heard of, quietly running one of the most important businesses on the planet. Here is the thing about TSMC. They do not design chips, they do not sell gadgets, they do not have a famous logo on any product you own. What they do is manufacture chips, and they are almost impossibly good at it. TSMC produces over 60% of the world's standard chips. But more importantly, they produce over 90% of the world's most advanced chips. The ones inside your iPhone, the ones powering NVIDIA's artificial intelligence processors, the ones running AMD's latest computers. Every major tech company in the world, Apple, NVIDIA, Qualcomm, AMD, they all design their chips, and then hand the blueprints to TSMC and say, please build this for us. TSMC is the world's most indispensable manufacturer, sitting on a small island in the Pacific Ocean. Now, if TSMC is the factory, then there is one company that builds the machines that run the factory. And this company is even more unknown, even more irreplaceable. That company is ASML. Based in the Netherlands, and they hold what might be the most powerful monopoly in human history. ASML is the only company in the world that can build extreme ultraviolet lithography machines. Say that 3 times fast. Extreme ultraviolet, EUV. These machines are the reason advanced chips exist at all. Each one costs around $250 million, each one is about the size of a school bus, and each one is a miracle of modern engineering. Here is what these machines actually do. They fire a laser at tiny droplets of molten tin, 50,000 times per second, to create a beam of extreme ultraviolet light. That light is then used to print microscopic circuits onto a silicon wafer. Circuits so small, they are measured in nanometers. For reference, a single strand of DNA is about 2 nanometers wide. These machines are printing circuits at that scale. ASML ships only a handful of these machines every year, and every single advanced chip in the world depends on them. Then there is NVIDIA, the American chip designer that has become the defining company of the artificial intelligence era. NVIDIA does not build its own chips. It designs them, hands the blueprints to TSMC, and sells the finished product to data centers, researchers, and governments around the world. Their AI chips, particularly the H100 and its successors, are the engine of the modern AI revolution. Every large language model, every image generator, every AI product you have ever used, almost certainly ran on an NVIDIA chip at some point. 3 companies, 3 countries, Taiwan, the Netherlands, and the United States, connected by invisible supply chains, mutual dependency, and enormous geopolitical risk. And now, one country wants in, and the rest of the world is doing everything it can to keep that country out. That country is China. China is the world's second largest economy, it has the world's largest population, it has enormous manufacturing capability, and for decades, it has been buying advanced chips from the rest of the world to power its technology industry. But in October 2022, everything changed. The United States government implemented the most sweeping export controls in modern history. The goal was simple: cut China off from the world's most advanced semiconductors and cut China off from the machines needed to make them. American companies could not sell advanced AI chips to China. American suppliers could not provide equipment needed to make advanced chips in China, and here is the part that made the whole world pay attention: the US also pressured its allies to join the blockade. The Netherlands, home to ASML, eventually agreed to ban ASML from selling its EUV machines to China. And not just the newest machines, even some of the older, less advanced DUV machines were later restricted. Japan joined the blockade and South Korea began tightening its own exports too. Suddenly, China found itself cut off from the entire global supply chain of advanced semiconductor technology. But why can China not just build its own machines? Why can it not simply reverse engineer ASML's technology and make its own version? This is where the story gets fascinating. Because making an advanced semiconductor is arguably the most complex manufacturing process in human history. It is not like building a car or assembling a smartphone. The process requires contributions from dozens of countries, hundreds of specialized companies, and decades of accumulated knowledge. The optics inside an EUV machine come from Germany, the laser components come from the United States, the control software involves engineers from across Europe, the silicon wafers come from Japan. It is a global collaboration that has been refined over 50 years. You cannot simply copy it, you cannot look at a finished chip and figure out how it was made. The knowledge is locked inside thousands of patents, millions of hours of engineering experience, and international supply chains that have been built over generations. China, for all its manufacturing power, is facing a wall it cannot easily climb. But China is not giving up, not even close. Behind closed doors, the Chinese government has launched what some insiders are calling their own Manhattan Project. A state-backed, massively funded push to achieve semiconductor independence by any means necessary. Reports emerging in late 2025 and early 2026 revealed something remarkable. Chinese tech giants, including Huawei and the state-backed chipmaker SMIC, have been operating secret laboratories. The mission? Reverse engineer ASML's machines from scratch. And it has not been going well. There is a now infamous incident that has been circulating in industry circles. Chinese technicians attempted to completely disassemble an older, unrestricted ASML machine to understand how it worked. They took it apart, component by component, and then they could not put it back together. The nanometer scale calibration of the machine's internal components is so precise, so unforgivably delicate, that reassembly without the original engineers is almost impossible. They ultimately had to call European technicians, the very engineers from the company they were trying to copy, and ask them to come fix the machines they were reverse engineering. That story tells you everything you need to know about the scale of the challenge China faces. But China is also playing a longer game. There is a brain drain campaign underway. Chinese companies and government-linked organizations have been aggressively recruiting retired and former ASML engineers from Europe, offering extraordinary salaries, massive bonuses, luxury packages. The goal is to get former insiders to help China build even a crude, basic prototype of an EUV machine by 2028. European governments have taken notice. The Netherlands has introduced new measures to monitor and restrict the movement of sensitive knowledge. Some engineers have turned down the offers, others have not. China's path to semiconductor independence is not a straight line. It is a long, expensive, painful climb. But the Chinese government has shown, repeatedly, that when it decides something is a national priority, it throws unlimited resources at the problem. The semiconductor race is far from over. While China scrambles to catch up, another giant is entering the race from a completely different angle. India. For years, India was largely absent from the semiconductor conversation. But the global chip war has created an enormous opportunity. As the world looks for alternatives to Taiwan, which sits in an increasingly tense geopolitical region, India is positioning itself as the safe, democratic, scalable alternative. The Indian government launched the India Semiconductor Mission, a massive state-backed initiative to attract chipmakers with generous subsidies and long-term partnerships. The pitch is simple. India has the engineers, the scale, the political stability. Come build here. And the biggest bet is already being placed. The Tata Group, one of India's most powerful conglomerates, has announced a partnership with Taiwan's PSMC to build an $11 billion chip fabrication plant in Dholera, Gujarat. One of the largest industrial investments in Indian history. And the timeline is aggressive. This plant is expected to roll out India's very first commercially manufactured semiconductors by late 2026. Not assembly, not packaging, actual chip fabrication. India going from zero to semiconductor manufacturer in the span of just a few years is a remarkable story. Micron, the American memory chip giant, is also building a major assembly and testing facility in India. More companies are following. The supply chain is beginning to route through the subcontinent. India is not going to challenge TSMC tomorrow. Nobody is. But India is rapidly building the foundations of a serious semiconductor industry. And in a world where geopolitical risk is the dominant concern, having a massive, stable, democratic country with a huge engineering talent pool enter the space is a major development. The chip map of the world is being redrawn. And India just put itself on it. So where does all of this lead? Let us talk about the future. Because the future of semiconductors is unlike anything the industry has ever seen. The global semiconductor market is expected to cross $1 trillion in annual revenue by 2026. $1 trillion! That makes it larger than the entire GDP of many countries. And the engine of that growth is almost entirely artificial intelligence. Every AI model needs chips to train on, every AI product needs chips to run on, every data center being built right now needs racks and racks of AI processors. The demand for advanced semiconductors is growing faster than the industry has ever experienced, and it is not slowing down. But here is the challenge. The physics of chip making is running into its limits. For decades, chips got better by simply making the transistors smaller. Smaller transistors, more computing power, less energy. But we are now approaching the boundaries of what is physically possible. You cannot make a transistor smaller than a few atoms. The laws of physics do not negotiate. So the industry is finding a new way forward. It is called three-dimensional advanced packaging. Instead of making chips smaller, engineers are now stacking chips on top of each other. Layer after layer, like floors in a skyscraper. This allows them to squeeze more power and efficiency into the same physical space without making individual components any smaller. It is a paradigm shift, and the companies that master it first will have a significant advantage in the AI race. Meanwhile, the era of a single global supply chain is officially over. Every major power on Earth has concluded that relying on one island in the Pacific for the world's most critical technology is an unacceptable risk. The United States is spending hundreds of billions to bring chip manufacturing home through the CHIPS Act. Europe is funding its own semiconductor push. Japan is partnering with TSMC to build fabs on Japanese soil. India is moving fast, as we just discussed. The result will be a more expensive, more fragmented, more redundant global chip industry, less efficient, but far more resilient. Geopolitics has entered the semiconductor boardroom, and it is not leaving. The world is reorganizing itself around chips. Around these tiny, impossibly complex pieces of silicon that nobody outside the industry ever thinks about. They run your phone, run your car, run every hospital, every power grid, every financial system on Earth. And right now, a handful of companies in 3 countries have their hand on the switch. The semiconductor war is not just about technology. It is about who gets to build the future. And that future, measured in nanometers, is worth more than any army. So there you have it, the chip war laid bare. TSMC holding the world's most critical manufacturing capability on a contested island. ASML sitting on the most powerful monopoly nobody talks about. China locked out and fighting to break free. India emerging as the world's next great chip hope. An artificial intelligence driving demand so fast the market is heading for $1 trillion. The next time you pick up your phone, remember, inside that glass rectangle, sitting on a chip the size of a stamp, are billions of transistors, each one smaller than a virus. Built by machines that cost as much as a Boeing jet. Shipped from an island everyone is quietly terrified about losing. That tiny chip is the most valuable object on Earth, and everyone wants to control it. If this blew your mind, share it, because this is the story of our time, and most people are sleeping on it. See you in the next one.